Hello everyone, welcome to our second week. We're going to continue talking about data visualization using R. So let me show you a quick story. This is from the New York Times. I like it because it shows in a graphical way like one of the concerns about data privacy. So the idea here in this article is that they're talking about the dangers of sharing your data. In this case, this is a database. It's a public database actually. They claim that that the database observations do not show like who's the person, but it shows like the cell phone where it was registered, like the location of the cell phone. So this is like the pings in different towers, cell phone towers. So let me show you the main idea. So they start saying that they can identify like different cell phones in different locations in the US, even in critical facilities like the White House and things like that. And then using data visualization, they just focus on, this is a Central Park. So they say, okay, here we have 10,000 smartphones tracked in Central Park, but then let's just focus in only one cell phone. So this one. And now what they do is, okay, now let's see that specific cell phone. Let's gather all the information in the data set. So now they have like multiple points for the same cell phone, for the same device, let's say. Now they start connecting the points, connecting the dots. So even though initially we don't know who's that person, now when you connect the dots, so now they start saying, okay, it gets scary because we can see like where that specific device was, like sleeping every single night. So they can identify where you live. At the same time, they can see like where you go, like to work. But even if you go to a park in the morning, they can track that. So showing the visualizations, it's really useful to make a point, right? So even if you're not reading the article, which it's a quick reading, the visualization part supports the story in a good way. So today we're going to continue with our analysis using R. Our plots are going to be a little bit more basic than the one I show you, but yeah, we're just covering the basics initially. Okay, so here we're going to talk about ggplot2. This one, ggplot2. It's one of the most recognized libraries in R for visualization. You can really create high quality plots with ggplot2, like paper quality if you're in academia, or even if you wanna you're creating a report and you wanna high quality, high resolution, you can get something good using ggplot2. All right, so let's try to understand how this works. So in order to do so, I'm gonna use the same data set that we were working last class. So remember the palmers, the penguins. I don't know if you recall. So let's bring that data set. So it's not remember I'm using Collab. So I need to install the package first. The name is Palmer's Penguins. Palmer Penguins. And when we install it, we need to load the library. So we call the library. So to run these cells, you can just click play, or in my case, Shift Enter will do the job with Shift Enter. You can check here, like how to run everything. If you want to run only a selection. All right. So I have loaded the library. I need also one more library. Let me load the tidyverse. The tidyverse is a collection of packages actually. I'm gonna add a hash sign here because I don't want to install again Palmer Penguins in the same session, because it will take more time. Just want to load the tidyverse, and that's it. So I have both of them. Again, if I need to install this package, I just remove the hash sign. That's to create a comment. But again, since I already ran once minimization, I'm okay. So I can just add the hash sign to make it a comment. All right. So now we have penguins. So this is the dataset that we're using in our last session. In Python, we will call it data frame. Here in R, it's called a table. So it's showing that we have a table here. There are 344 observations, so different penguins, and 8 variables. So you have here, each of them are factors, like the species, the island, and then there are other metrics, build length, build depth, flipper length, body mass, more factors here, sex, and year is an integer value. Okay, so when we have the information already, so now let's start visualizing our data set. So just to give you an idea, this is a penguin. We have the build, so build length, build depth, because we're going to use these variables. All right. So the first one, it's using ggplot, create a plot to visualize build length and build depth to see if there is a relationship between these two variables. So let's do that. So I'm going to use the ggplot function, and the structure is you need to first provide the data. In this case, it comes from penguins. Then you can do that in the same line. Then we need to provide a mapping. So the idea of the mapping is that you're going to say, okay, which is going to be the x variable, the y variable, color, shape, in case that you want to add all those features. So in the mapping part, we provide all that information, like which variable is going to which x or y, to which variable x, y to which axis, or to the color, or to the shape, or any other features that we may add here in the mapping. So the mapping is going to be equal to the aesthetics. So we're going to use the AES, aesthetics. So in the X here, we want to see the build depth. This is the variable. The Y variable is going to be the build length. Okay? So if I plot this, you won't see anything. So it's just like an empty plot. So it recognizes, okay, the data comes from penguins. In the mappings, it recognizes that, okay, the build depth is in the x-axis and the build length in the y-axis, but it's not showing points. That's because we haven't added the geom. So what is that? Let me show it to you. Here then, I'm adding a geom. In this case, I want to see like a scatter plot, so it's a geom point. There are geom lines. Let me show you like all the possibilities. Geom bar, geom box plot. So this is the way in which ggplot is going to display the information. So how we are going to visualize it. So in this case, since I want a scatter plot, I'm going to use a geom point. You can get a geom histogram, like the different ways to represent that information. Geom point. And now, with the geom point, we get the information that we want. So this is our plot. It looks kind of messy, right? Because it shows like a lot of variability. But remember, the thing here is like we're using only 2 variables and there are 8 variables. So there are other variables that are affecting our data. So You gotta be careful because sometimes when you visualize something and you use only two, you think that that's your whole universe, and you try to understand everything but only by what you're seeing. But that's you gotta be cautious because sometimes uh, some variables will affect here. So, for example, there are multiple species here. So some of those species are smaller, others are bigger. So of course that's going to affect our numbers. So let's try to add more variables into our plot so we can understand better if there is a kind of like a relationship between the build depth and the build length. So in order to do so, here in the static part of the mapping, I'm going to add color. For the color, I'm going to use the variable species as a factor. Now it's gonna ggplot2 is gonna assign to each species a different color, and actually it's gonna add a legend here showing like which color belongs to which species. Alright, so once we do this, now even though we get the same plot, now it is easier to understand because now we can see that okay, there are three different species, we have the colors, and now you can see like for each species there is like a trend, like a relationship. It's more clear because initially it was a little bit messy our plot, but now we can see that for each species it makes sense, or you can see at least a clear relationship, like almost linear, I would say in some cases, between the build depth and the build length. So as one increases, the other increases, which I think is reasonable. There are some outliers here you can see, like for example, this piece right here, in this part. This is a hint too, so it's kind of like far from the other observations. I mean that's possible. Also here, if you notice this one, it's like the build length it's high compared to the others, right? But that's just variability. That's just variability. All right. So if you notice the structure of ggplot2, it's simple, just data, then the mapping, which variable, like what value it's gonna get, and even the colors and even shapes. We're gonna add shapes later, and then we need to add just the geom, like how you want to select. Even you can add multiple geoms. We will see that later in some cases. All right. So there are two questions here. Now let's analyze if flipper length has a relationship with the mass body, with the body mass. So let's do that. So it's ggplot. Now you know it's data. So since you know that it's data, you don't need to type the data equal to. No, if you remember like the order, you should be fine. So this is just data. Then we have the mapping. So for the mapping is aesthetics x equal. Now we want the flipper length then for y we have the body mass we can add the color right away. For the color, species. Let's add a geom, point it again. It's important, I'm sure you're getting this message here. It's just a warning, it's not an error, it's a warning. It's because ggplot2 or R is letting us know that there are like two rows with missing values. So they are removing that, right? So this is warning just to let you know, like they are removing those two rows in the process. So it's not an error, it's just a warning. Okay, so here we can see again the relationship now between the flipper length. So the higher the flipper length, the higher the body mass. It's almost linear. That relationship, yeah, I would say it's linear. It's really strong, regardless the species actually. Okay, now there's a second question like that we should have like a smooth curve displaying the relation between body mass and flipper length. It's like a linear regression to see if I can make a line here to get closer to like most of the points. So let's add a linear function with the geom smooth. If I leave it like this, it will do something more like exponential or even like a polynomial thing. You see the curves? But I want a linear. So the method, I'm going to define it as linear, or LM, the linear model. And I'm getting 3 lines actually. I'm getting 3 lines, one per species. So what if we want to get only one? Let's see why. Let's try to understand why we're getting like 3 different lines. Which is, I mean, that's not bad. It's just like the thing is like here when we were defining the map in the aesthetics, we define color here with the species. So now the ggplot to the other layers, it's keeping this absolute value, like species, like a separate variable. So if I wanted to be more specific, so if I wanted to keep it the species only for the geom points, but I don't want to like differentiate the species in other geoms, so I'm going to remove it here from the global part, and I'm going to add it only here in the geom point. So the aesthetics here. Will be the color species. And now we should get only a single line. So this is our linear, model. Which again, I'm pretty sure that we can train here like a regression model to be able to predict body mass based on flipper length. All right. So let's continue. So let's keep improving our plot. Now let's add like title, subtitle, labels for the axis, just to make it a little more interesting. So we can keep the code. We can just copy and paste our previous code here. Now, if you notice, we only have added color to our observation, but also we can change the shape for the species. We can do that if you want. So here in the aesthetic part of the geom point, so let's call it shape. This is optional, but maybe in my case I have difficulties, identifying the different colors. So with the shapes, for me at least, it's easier to analyze the plots. Okay, so now we have the two things, the color and the shape. And let's add our labels. For the labels, we have the title. Let's add a nice title to our plot. That will be body mass and flipper length. We can add subtitle. Again, this is optional. All of these. Dimensions for the three species. Right? Next label. The filter length. Y label. The body mass. The color. Species. And for the shape, we're also using species. Alright, so it adds the title, it has the title, the main, the subtitle, x-axis, the y-axis, the labels, and even here in the layout, if you notice, now we have like uppercase pieces. Previously it was same as the variable of the in the dataset, but sometimes the variables in our datasets they have like different names, you know, like with symbols or maybe some abbreviations, but you can change it too, as we just did here in this part. All right. So now we have improved our plot, so we can continue analyzing or creating different plots. So now let's create bar plots. This data set. Remember the different variables that we have. So one is species that we have used a lot. There are 3 values. Those are the 3 values. We can create a summary. Or even a table to count them. So here the summary is counting them. The table. With the table you can also count how many observations you have of each level. So there are 152 of the first one, 68 of the second one, and 124 of the Gen 2. Okay, but now what if I want to create a bar chart? So let's create a bar chart. Using ggplot. So the structure is the same. ggplot, the data, penguins, aesthetics, that's the mapping. So X here is going to be the species. And I'm going to add a geom, but in this case that's geom bar. And it gives you the bar chart for the 3 species with the frequency values. You can change the color if you want. Let me show it to you. I'm going to add it here. In the geom bar part, there are some parameters that you can customize. So the fill, I'm going to change it to width, and the color, this is for the border, it's going to be black. That's how you can create, like a customized bar plot. You can change the color, you can play with the fill. So there are many things that you can do here. By the way, these plots, you can save them. So with right click, for example, you can copy this image. Let's say I want to send an email to someone, and for some reason I need to show the plot. So you can just copy and paste it, and it will work. It will keep a decent quality, if you notice. So you can copy and paste it in a report, and yeah, there won't be an issue. Now, if you require way more quality than that, then I don't recommend you to do just the right click. There are some functions like ggSave, where you can kind of like define the quality of the plot. So you can find that. You can find that. But for our initial purpose, you can just copy and paste and use them right away. Okay, so let's continue. Now I'm going to create a histogram. So by now you understand the idea. What changes only is the geom, not the geom histogram. So I'm going to do I'm going to use my variable. Let it be body mass. For the histogram, I need a numerical variable. For the bar chart, I was using a categorical one, but the histogram requires a numerical variable. So I'm going to use the body mass for that purpose. So ggplot dataset, the mapping, and if you want to type data equal to penguins, mapping equal to aesthetics, and then x, y, and the other things, you can do that. But if you know the order, which I'm pretty sure that after 2-3 plots, you already know the order. So x, in this case, is going to be the body mass. There's only one variable. And then we add the geom histogram. So here you can modify the number of bins if you want, the bin size. You can change colors too. Like you can check the parameters of geom histogram. And also, I'm going to attach a cheat sheet provided by ggplot, where you can get all the codes for all the different geoms, at least the most popular geoms here. I'm going to upload it, but you can find it easily. So it shows like different geoms that you can use. So we're using geom point, this one, but there are like a lot of geoms here. So depending on the case, if you have two variables and both are continuous, but if you have 3 variables or only one variable, you can use different things. So later we'll use the box plot. I'm going to create one box plot. Just give it a look here, and I'm pretty sure that you will find the plot that you need. If you are dealing with discrete variables, the geom bar that we just used, and here you can change other things of the plot, like the scales, the metrics that you compute, the coordinate system. So by default we're using the Cartesian method, but you can change it to polar system and other systems. You can flip the axes if that's what you want. We can add facet in here. So this is when you have like multiple plots per row, per column, or even you can get like a matrix of plot. We will do that also in this video. Or the labels with labs, we just did that. To add title, subtitle, x, y variable, or even if you want to annotate here, like inside the plot, you can do that too. Maybe like to show a specific point. I mean, you can customize, like the plot. I haven't used this. You can zoom. All right. So I think at this point you get an idea. It's like there are a lot of alternatives here, a lot of options to personalize your plots. You don't need to memorize them. I mean, there is no point to memorize them. You should know the basics, of course, on how to create them. And then, depending on what you need, you will be able to figure it out. All right, let's continue. So we created our histogram, and I told you that I want to create a facet. So let's do that. Let's create a facet. So the facet is to create multiple plots. All right. So I'm just gonna copy and paste my initial plot, the one with the build length and the build depth. This one. And let's add more variables here. All right. So this is the plot that we have. That was the initial. It's just build depth in the x-axis and build length in the y-axis. We have colors. I forgot to add shapes, but that's up to you if you want. Now let's add the facet. So imagine that there is one more variable here. The name of the variable is the island. So in which island is like they collected the data. So let's add that island as a new variable. But not in that process, I want to create like more plots. So I'm gonna have like a one row with multiple plots. So one plot per the value of the new variable. So that's the facet graph. Tilde and the name of the variable that I want to use for the faceting. Okay. So now I'm getting three plots. That's because there are three islands: Bisco, Dream, Torgersen, and now I get the same original plot, but for each island with information of each island, just to check if there are some differences. For example, in the third island there is only one species, and in the other islands there are two, if you notice. So you can create a matrix of plots to analyze like more variables, because even though we're using here like 2 dimensions to analyze our plots, now when we start adding color, shapes, and now facets, we can easily create plots with 4 or 5 variables. You have to be cautious because remember, you don't want to miss the point, which is like interpretability. But if it's useful to identify patterns, so you're welcome to add these variables. But again, you have to be strategic in the way in which you add them as colors. And of course, when you are doing the facet, for example, this is for discrete variables or categorical variables, like with few values. But if it's a continuous variable, then you will get an error, you will have problems. All right, let's work now in a second data set. The second data set, it's MPG. Let me show it to you. MPG. So it shows like different cars, 234 different cars, and it has 11 variables. Like the manufacturer, the model. This is information about the engine, number of cylinders, and the key variables here are the city and highway miles per gallon. These are like the 2 key variables in our dataset. Now, if you know that, remember, you can always check help. So the MPG dataset, it's located in the ggplot2 package. Since I loaded the tidyverse at the beginning of the session, that's why ggplot2 it's available. In case you're using RStudio in your local computer, then you will need to, again, same thing, to call the library tidyverse or just ggplot2. And here you get the same information. So manufacturer, model name, this is the engine displacement, year, number of cylinders, type of transmission, DRB, is the type of drivetrain, city miles per gallon, the highway miles per gallon, and the fuel type, and the class type of car. Okay, at least now we have an idea of the plot, of the information in our dataset. In the tidyverse, there is a function which I tried to use in our previous video glimpse. It's just the transpose of the table or of the data frame. Glimpse. So it's the same idea. It shows the variables, what type of variable, and some of the initial values, number of observations and number of columns. It gives you the same idea. Okay, so let's create our plot. Here we want to try to create a box plot. We use the ggplot. If I just do the mpg, again I will get an empty plot. It's not the same with the R-base package. In the R-base package, if I do the plot, which is the basic function in the R-base to create visualizations, and I provide the mpg, it will try to visualize, provide a plot for each pair of the variables inside that data set. So let me show it to you. So this is like a pair plot. It's a pair plot. So each figure here, each plot is just the intersection of two variables. It's like a scatter plot of two variables. So you need to check, like for example, manufacturer here will be in this row and will be also in this column. So the intersection with the other variable will give you, like, it will change like in which part is which is your x axis and which is your y axis. But again, the way to understand this is like if you see, for example, here displacement. So it's going to be in the column, it's going to be in the x-axis, and in the row it's going to be in the y-axis. All right, I'm going to keep adding information here, the aesthetics. So for the aesthetics, I want to analyze, let's say, the highway variable, the highway consumption, miles per gallon, and the class of the vehicle, if it's a compact vehicle, SUV, things like that. So the X variable is going to be the class. The Y variable is the highway miles per gallon. So if I leave it like this, again I'm going to get an empty plot, but now it recognizes the X's, class, and the values for the class. So cedar, compact, midsize, minivan, pickup, subcompact, SUV. For the highway, it recognizes the values. But remember, we're missing the geom, right? So here, I want box plots, no points, so it's geom, box plot. So it creates a box plot. It's simple, the structure is the same. The structure is the same. We're just changing the geoms, some features or the variables order, things like that. So now we can see the different box plots for each class and the consumption in the highway. And it makes a lot of sense. If you notice, for example, compact cars or a mid-size, they are the cars with, they have the highest values of miles per gallon in the highway. Now, the pickups and the SUVs, they have a higher consumption. That's why the miles per gallon, the numbers are lower compared to the other vehicles, which makes sense. It makes perfect sense. All right, so in this video, I just wanted to give you a quick introduction to using ggplot2, the library ggplot2, especially the function ggplot and the different geoms. So in the next video, we will talk about how to transform data, how to select specific column, rows, filter our data. And in the homework or the assignment, You will practice both. You will practice some visualization and some data transformation. So I'll see you in the next video.